Welcome to Carlton's Math Corner. Today we're going to be going over the Chapter 4 vocabulary. So to begin, will you please make sure that you have your vocabulary packet as well as your math journal. While we go through the different vocab terms, I would highly suggest that you record any sketches that you don't have, any vocabulary terms that you don't have, or even just any terms that you are still unfamiliar with. Because the more that you record them and the more that you write them, the better chances are that you're going to recall them and remember them for the test. So let's start off with our first word, and the first word is fraction. Now we worked a lot with fractions because our entire chapter had to do with rational numbers, and rational numbers can be written as a fraction. And so here are some examples of fractions. And the biggest thing about a fraction is that a fraction is a number that represents a part of a whole. And so the part is the numerator, and that's on the top. And then the whole amount is in the denominator, and that's down in the base. Now, a fraction can also be represented as a decimal. And so that is our next word. Here are some examples of decimals. And can you recall what the definition is of a decimal? Correct. A decimal is a number that shows place value, and it is separated by a decimal point, and there is an integer part and then there's a fractional part. Now, we've been talking about fractions written as decimals, and now decimals can also be written in a different form as well, and that form is called a percent, and that is our next term. Can you think back to our lesson on percents, and what does the word percent mean? Exactly, it means per 100, and that's what a percent is. You're trying to determine how much value is it per 100, and so like 3/4, we're trying to figure out how many boxes are we going to shade out of 100 that represents 3/4? And so 75% would be equivalent to 3/4. So if percent means per 100, then basically we are just finding the amount per 100. And so that is our definition of percent, is an amount per 100. Now, in our chapter, we also talked about least common multiple. And here are some examples on how we found least common multiple. And we called it LCM for short. What definition would you give least common multiple? Exactly. It is the least multiple shared among two or more numbers. So for instance, here's the multiples of 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, etc. And then multiples of 4 are 4 times 1 is 4, times 2 is 8, times 3 is 12, etc. And do you notice, there are two multiples that are listed that they share. However, we're looking for the least, the smallest one that they share, and the smallest one is 12. And so their least common multiple for 3 and 4 is 12. We also looked at greatest common factor. What definition would you give greatest common factor? Exactly, we are finding the greatest factor shared among two or more numbers. So here are the factors of 16. 1 times 16 is 16, 2 times 8, and then 4 times itself is 16. So these are all the factors of 16, and then these are all the factors of 24. And the greatest factor they share, because if you notice, they share 1, 2, and they share 4. And then lastly, they share the number 8. And so because 8 is the largest number they share, or the greatest number they share, that is their greatest common factor. Now let's talk about what are factors, because that is one of our terms, and this was a term that we worked with in chapter 1. So what are factors? Oh, you guys are so good. Factors are just numbers that we multiply together. And so we made these little rainbow trees to list all the factors of numbers. 1 times 24, 2 times 12, 3 times 8, 4 times 6. These are all factors of 24. And then here are the factors of 36. Now, speaking of factors, we also looked at prime factorization. And so just to clue you in, factor trees, do you remember those? And what definition would you give prime factorization? And the key word is prime. And then within factorization, there's the word factor. So what definition would you give it? Yes, it is the product of factors of a number, but we are going to squeeze in the word prime because it's so important. So it's the product of prime factors of a number. And what are prime numbers again? Yes, prime numbers, remember, are numbers that only have 2 factors. They make one rectangle. Remember, like 7. The area, if I make a rectangle to find the area of 7, or has the area of 7, it'd be 1 times 7. And that is the only rectangle I could create to get that area. And so it has 2 factors, and that makes its prime. And so here's an example. Here is a factor tree, actually, of 100. 10 times 10 is 100. 2 times 5 is 10. 2 times 5 is 10. And notice these are circled and are in yellow. They're highlighted because these are all prime numbers. And so when we get down to prime numbers, then we can stop because we are done. And so I noticed that we have 2 2's. So I wrote those down, and we have 2 5's, wrote those down, and then we simplified it for us and basically wrote it with powers so that it is in simplest form and so that we really don't have to write as much. 2 to the second power shows us that we have 2 2's, and 5 to the second power shows us that we have 2 5's. Okay, and that's prime factorization. Notice the numbers that we have left are our prime numbers. Okay, we have no composite numbers. Okay, so let's look at our next term. Next one is mixed number. Well, a mixed number, what definition would you give that? Looking at these pictures, what are mixed numbers? Yes, mixed numbers are numbers that have a whole number and a fractional part. So like this number line actually shows that there is 2 wholes. See, 1, 2, and then there's a little bit more, and if you notice, these are separated into 1, 2, 3, 4, 5 equal parts, and 2 are shaded. So that means it would be 2 and 2/5, and that would be the mixed number, 2 and 2/5. Now over here we have 1 whole pie, and then we have how much left? 1 out of 6, so 1/6. So 1 and 1/6, and that is our mixed number. The next term that we talked about is equivalent. And what definition would you give equivalent? What did we talk about? And looking at these images and making some observations, what definition would you come up with? Correct. They are rational numbers that have equal, they're equal in value or an amount. So like 1% is equivalent to 0.01, and it is equivalent to 1/100th. These are all the same amounts, or all the same amount, however, they're written in different forms, but they are all the same. They equal the same amount. Okay, and that's what makes them equivalent. Our next term is simplest form. And what definition would you give to simplest form? Yes, correct. Simplest form means to just reduce, and we mostly worked with fractions and with simplest form. And so reducing a fraction, basically that means that we reduce it so that the numerator and the denominator cannot be reduced any smaller. So like if I start off with 24/108ths and I divide by 2, well, this is now 12/54ths. I can still divide by 2, so I have to keep going. And then I get 6/27ths. And I notice that 3 goes into both of them, so I can still divide by 3. I keep going until I can't reduce anymore. The numerator and the denominator may not be reduced anymore, so 2/9ths, there's no other number that would go into both of them. And here's some other examples. Start off with 24/40ths. Went to 12/20ths, but you know what? I still could reduce, and notice if I divide by a larger number in the beginning, I could get down, simplify, even quicker. If I divide by their greatest common factor, which is 8, 24 divided by 8 is 3, and 40 divided by 8 is 5. And so 3/5 would be what I would get down to when I simplify it and put it in its simplest form. So 24/40ths is equivalent to 3/5. Now, ratio is our next term. And what definition can you think of for that one? Yes, it is a comparison of two or more numbers that have the same unit of measure. So I can compare people, like teachers to children. I can compare fruit, apples to oranges. I can compare animals. I can compare, colors, whichever, I can compare anything as long as they are of the same unit. And we talked about writing ratios. We can write them with a colon. We can write them with the word to, T-O, or we can write it as a fraction. And remember, writing them as fractions, though, we need to make sure that we have a total amount at the bottom of the fraction. So like I would have to have the total people, the total fruit, the total colors, whatever I'm comparing, to create that fraction. Our last term, yay, is called inequality symbols. And what definition would you give for those? Correct. They are symbols that are used to compare two numbers. And we talked about greater than symbol and less than symbol. And then we also talked about equals. And so we use them to compare different numbers. We compared percents, decimals, fractions, etc. So all rational numbers. Well, thank you so much for joining me at Carleton's Math Corner. And I hope now you are prepared and ready for the vocab test. Well, have a nice evening and Can't wait to meet with you again.